Hello students, good morning. Welcome to my lecture on chapter number 10 Halogen Derivatives, class 12 Science, Maharashtra State Board New Syllabus 2020. In the previous lectures, we have started optical isomerism in halogen derivatives. As well as in that lecture, we have studied some concepts, stereoisomerism, chiral carbon atom, which is also called as asymmetric carbon atom, chirality, and optical isomerism. Now you know that the optical isomers are differ from each other in terms of measurable property that is called as optical activity. But before going to study optical activity, you must know the concept of plane polarized light. Now see this figure. This is ordinary light. It shows all possible planes because ordinary light consists of what? Electromagnetic waves having oscillations of electric and magnetic field in all possible planes perpendicular to the direction of propagation of light. Perpendicular to the direction of propagation of light. This is what? Direction of propagation of light. But if this ordinary light pass through this nickel prism, then you get what? Plane polarized light. But first, we will know about some things about nickel prism. Nickel prism is a special type of prism which consists of a piece of calcite. Calcite is a crystalline form of calcium carbonate, which pieces are arranged in specified manner, then you get what? Nickel prism. This is also called as polarizer. Polarizer. Then you get what? Plane polarized light. Now we will see how nickel prism works. This is the window having iron rods. These are what? Rods. Iron rods. If I will throw this pen through this window, then it will not pass. But if this plane is in proper plane, then it will pass to this window. So working of window is similar to working of nickel prism. Therefore, ordinary light when pass to this nickel prism, you get plane polarized light. Now what is meant by plane polarized light? See, plane polarized light having oscillations only in one plane. Perpendicular to the direction of propagation of light is called plane polarized light. Now, when this plane polarized light, see here there are oscillations in only one plane. If any sample solution is placed in the path of plane polarized light, then there are two possibilities. If the sample solution is optically active, then you get this type of oscillations, because when this plane polarized light pass to this sample solution, then the transmitted light have transmitted light have different oscillation than the original one. But if the sample solution is optically inactive, then there is no change in the oscillation of plane polarized light. Now come to the term optical activity. Now come to this concept optical activity. The property of substance by which it rotates the plane of plane polarized light is called optical activity. Means when this plane polarized light passes through the sample solution, the plane polarized light gets rotated. So it is called as what? Optical activity. Now optically active compound. See, optically active, optically inactive. Optically active compound means what? The compounds which rotates. Which rotates the plane of plane polarized light are called optically active compound. Means you get this type of optical rotation when compound is what? Optically active. Now next, optically inactive. See, this is optically inactive compound. The compound which do not rotate the plane of plane polarized light. Is called optically active compound. Optically inactive compound. Now you understood optically active compound. Optically active compound rotates plane of plane polarized light. In this manner, it may be clockwise or it may be anti-clockwise. But if compound is optically inactive, there is no change in the plane of plane polarized light. Now we must know one more concept, that is what? Optical rotation. Optical rotation may be positive or negative. Optical rotation means what? It is the angle of rotation. So optical rotation is what? The angle through which substance rotates the plane of plane polarized light. Plane polarized light on passing through it is called optical rotation. Means optical activity is measured in terms of optical rotation. Now on the basis of optical rotation, there are two types of optically active compound. First one is what? Are of two types. First one is dextrorotatory compound. This is Leo rotatory compound. Remember here, rotatory compound they are represented as D or plus sign, but Leo rotatory compound they are shown by small letter L or by minus sign. See, rotatory compound are those compound which rotates the plane of plane polarized light towards right are called as dextro rotatory compound. And you remember the meaning of the word dextro is what? Right. Similarly, come to Leo. Leo means what? Left. So the compounds which rotates the plane of plane polarized light towards left are called as Leo rotatory compound. They are shown by L or minus sign. Now come to know non-superimposable and non-superimposable and superimposable. We must know about what non-superimposable and the superimposable. Mirror plane. So what happens? OH come to left side, it is what? Lactic acid. It is what? Propane. Now, see, if you put left hand and place your right hand on this, then they may be coincide. So it is called as what? Superimposable. But if mirror is placed in front of this my left hand, then you get this type of image. They do not coincide. So it is called as what? It is what? Non-superimposable mirror images. Non-superimposable mirror image, because they are not coincide. I hope you understood the concept. Now come to this lactic acid. This is asymmetric carbon atom because 4 different groups are attached to this carbon. Methyl group, CH string, hydroxyl group, carboxyl group and hydrogen atom gets attached to this carbon atom. Means this is what? Chiral carbon atom, which is also called as asymmetric carbon atom. It is shown by asterisk. Similarly here, this is also lactic acid. See, this is the mirror image of this D-lactic acid. It is called as what? D-lactic acid. In D-lactic acid, OH is on right hand side. But see, in L-lactic acid, OH is on left hand side. If you put this D-lactic acid and place over this L-lactic acid, then they do not coincide. See, H will come on OH and OH will come on H. So they do not coincide. So they are what? Non-superimposable. They are also called as what? They are also called as enantiomers. Enantiomers. Now come to superimposable. Superimposable means what? See, if you place this propane over this, then they may get coincide. So propane is what? Optically inactive compound. Optically inactive. and lactic acid is what? Optically active compound. Okay. Now enantiomers means what? That the optical isomers which are non superimposable mirror image of each other are called enantiomers. But enantiomers, they have similar physical properties. They have what? Similar physical properties except sign of optical rotation. Because optical rotation may be positive or negative. If optical rotation is is clockwise, then you get positive angle, and so this can also be shown as what? Plus lactic acid. And if optical rotation is anti-clockwise, then you get what? Minus. It is minus lactic acid. Follow? Enantiomers, they have also similar chemical properties except towards optically active reagents. All these are about enantiomers. Now come to last concept, that is racemic mixture. Racemic mixture, which is also called as racemic modification. See, the equimolar mixture of enantiomers is called racemic mixture. They are shown by DL or DL, example DL lactic acid or plus minus lactic acid. Example means they are shown by what? DL or plus minus. But racemic mixture is what? Optically inactive. First of all, if you consider D lactic acid, quantity, then the rotation caused by D lactic acid, which is what? Clockwise, but the rotation caused by lactic acid is what? Anti-clockwise. So the rotation caused by D lactic acid is cancelled by rotation caused by L lactic acid, and therefore there is no change in the plane of plane polarized light. No change in the plane of plane polarized light. So they are what? Optically inactive. I hope you understood this concept. Now in the next lecture we will start chemical properties and different types of reactions.